Hello everybody and welcome back to another video on Discovering Code. आज हम solve करने वाले हैं a new problem which is called Luntik and Subsequences. Okay, sorry, my pronunciation was a little bit off because when we as Indians hear something start from these three specific characters named L, U, N, then something comes into our mind which is not very clean in nature. So, you know, this is always pronounced as Luntik. Now, his name could be Luntik, like that, but I will always say it as Luntik. With that out of the way, let's get into this problem. Let me start the timer really quick and we can get into it. All right. Luntik came out for a morning stroll and found an array A of length n. Okay. He calculated the sum of S of the elements of the array from I equals 1 to I equals n. And the sum of all those elements. Luntik calls a subsequence of the array A nearly full if the sum of the numbers in that subsequence is equal to S minus 1. Okay, so we have our first bit of information near, oh, my bad, there we go. Nearly full when a subsequence and not a not a subarray, but a subsequence. Okay, subsequence sum equals S minus 1. Now, let's read the question more. Luntik really wants to know the number of nearly full subsequences of the array A, but he needs to come home, so he asks you to solve the problem. I also need to go to home, so why don't you solve your own? Okay, never mind. A subsequence X is a subsequence of sorry, what? A sequence X is a subsequence of a sequence Y. Sequence X. Okay, let me draw. This is too thick. That's what she said. All right. Sequence X of a subsequence of sequence Y. So Y is a sequence. In this, we have a subsequence which is called X. Great. If X can be obtained from Y by deletion of several, possibly all or zero elements. Oh, it's just the definition of a subsequence. Ah, my bad. Thought it was part of the problem. My bad. So where's K? All right, input. The first line contains t equals 1000. All right, so this is the only thing that we got, and what we need to find out is the number of nearly full subsequences that we can get from the array A. So the only piece of information that we did receive was this. Now find the total number of subsequences that are full in array A. This is what we need to find out, and now we will do the time complexity. Oh, that is right. Analysis. So we are given time limit per test is 1 second, and we know 1 second allows us to do somewhere around 10 to the power 8 or 9. I think it was 8. Yeah, 8 operations. Uh, and we have around 1000 test cases. So if we look at it, 10 to the power 8 divided by 1000 gives us what? Somewhere around 5, 10 to the power 5 for uh, for a safe limit. No, sorry, not for a safe limit. What am I doing? Uh, Number of test cases we have, the max number of test cases that we can have is 1000, and the total limit per test, so including all the test cases we could go, is 10 to the power 8. So for if we power 5 is safe limit for us for each test case. Okay. The next two into T lines contain description of test cases. The first line contains n, and then the next line contains the array, which could go from 0 to 10 to the power 9. So I think 9 can be, and what do we need to do? We need to find the sum, right? Okay, sum, if we're doing, then we'll need to store it in a long, but yeah, we can have it in a normal integer array, but the operations that we would need require to do would be in long. So operation sum for subsequences long, but normal uh, sorry, uh, what's the name, uh, storage data structure, the normal integer array we can use. All right, that's how it is. I think this is the best thing that I could find. Now we'll start walking through the example, shall we? Let's start and take a look at the example. Okay. I mean, all right. So it's also given that the test cases, single integer, the total length of the array will go till 60, right? So we could add those into our calculations as well. So this is the number of operations that we have, and n into the total number of test cases that we have. So let's say 60, the highest. So this gives us somewhere around 6 into 10 to the power 4. So I mean, this total is well below the limit that we are provided, which is 10 to the power 8, and this is for all test cases. So I think we can safely this implies we can easily do a solution of O of n or O of n log n. So that is the complete reasoning. And now we can jump into the question itself. So what is our first input? So we have, all right, let me write it down. We have n equals 5 Then we have 1, 2, 3, 4, 5. Great. Now our S is what? Uh, he calculated the sum of the sum S of the elements of the array is subsequently full if the sum of the number of that subsequent equals to S minus 1. Acha. Okay. So this is a subsequence. Correct. Okay. Mm, 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 mm. Da, 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 da. Sequence X is a subsequence if X can be obtained from Y by addition of several zero or all elements. Okay. We need to find number of nearly full. Okay. Why is each and every one of them elements not a subsequence onto themselves? Like S will be 1 here, and for this subsequence S minus 1 is equals to 0, correct? And what we are given is, where is it? Where did it go? Yeah, the number of subsequent in the size equals to S minus 1. So, so the total number of elements must be equal to S minus 1. Oh, okay. Yeah, 0 is not equal to 1, guys. That's something very stupid. So that is not a good subsequence. Then what is a good sequence? As we can see from here, this whole thing is equaling to 15, and a nearly full subsequence is this, which equates to 2 plus 3, 5, 10, 14. 14. S is equals 15 and S minus 1 equals 14. Therefore, we can return this as one answer. Do we have any other such according to note? We don't. In the second one, both of them are equal. So we can't find any. I mean, the total sum will be 2000 and we need to find 1999, which is impossible. So that is impossible for this 10. What do we have? It's literally the case we just took. The third test case, S is equals to 1 plus 0, which is 1. Okay, so S is basically all of the sum. Oh, okay. Yeah, it's given. It's given that S is the total sum of the array. All right. I was thinking S was also modifiable, which is why I got very confused. But now I understand. I got it. So 1 comma 0. Wait, not this. Array is equals to 1 comma 0. Something like that. Now the sum, what is our S? S is 1. Now do we have a subsequence? Obviously we have 1 over here. And then empty is also one subsequence. So we got 2 as our answer, as provided here. We got 2000. So I mean, s minus 1 is 0 here. So whenever s minus 1 is 0, we can always say, if we have a 0, then we can say we have the number of zeros plus an empty. Only in this case, we will count the empty subsequence. Otherwise, we'll let go of it. Okay. Okay. What is the intuition behind the solution though? What do we think? How can we reduce this problem so that we could easily solve it? Is our next question. Uh, okay. So, okay, let me do this instead of that. We can remove that. So, solution. How should, if s minus 1 is equals to 0, s is equals to 1, can count the number of zeros at the empty subsequence into it. That's our one thing that I noticed. What are the other things that we can see? Let's take this one because for these it's not given. So we'll have to think those through. 3, 0, 2, 1, 1. What is our S here? So 3 plus 2 is 5, 6, 7. 7 is our sum. S minus 1 is a 6, correct? So I can directly see that this is one subsequence and that's it. Yeah, that's it. Okay, but it's saying we have 4, which kinda is not making any sense to me. How is it 4? Isn't s minus 1 equal to 6 here? Wait, sorry. No, 2, 4, 4 plus 3 is 7, right? Yeah, right. Yeah. Then how is it getting 4 as an answer? Uh, do we get wait, it said subsequence. Oh my God. Yeah. So in subsequences, we can skip an element. So it doesn't matter if we have, say, because sub-array, it's important to be connected, but we could have, let's say, this element, we can skip it directly. So we can have 3, 0, 2, 1, 1 as one subsequence. We could have 3, 2, 1 as one subsequence, and then we can use this other one and not this one. So we could have 3, 2, 1 with that other one. So this one is this one, and then this one is this one. So that is 3 of them. What's the fourth one? 2, 4. What's the fourth one, guys? Why am I not seeing it? Oh, sorry, yeah. Again, with this one, we pick this one, and we could again write 3, 0, 2, 1 with this one. Now, this is easy to do on paper, but to do this on a on a code. To do this in code, we'll have to do DP, obviously. Whenever we're thinking of subsequences, DP directly comes to mind. But is it really? I mean, it does kind of look proper DP to me. Like for subsequences, recursion is the only way we could handle it. But let me do some Google research and let's see if there is any other way to figure out subsequences except recursion. DP. Oh, okay. Iterative loops, BFS, DFS. I mean, BFS, DFS again, isn't it like using the principles of recursion? So I don't really know. But combinatorics, I think combinatorics is a funny one. I absolutely think there is something with combinatorics here, but we need to find it. Uh, 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 so, hmm, let me erase all this first. Clean it up. Let me clean this up and I will see you in 2 minutes. All right. So I have created the file name for this problem and I think I do understand something. So instead of looking at it with the eyes of subsequences, why don't we focus on this? So s minus 1, right? We are looking for subsequences whose total sum is equals to s, correct? Now in any subsequence, if we only are removing just one from it, then the max number that we can exclude from the array is what? 1. Nothing greater than this. No other number we can remove from the array which is greater than 1. So any of these 2, 3, 4, 5 we cannot remove because uh, we require it for the calculation of our s, and we need to find s minus 1, and s minus 1 meaning we need to exclude just 1 from the total sum, and we can also exclude as many zeros or include as many zeros as we want because it has null effect, like no effect. We can include it, we can exclude it, like shown here. We can either remove it or include it. So with this idea, let us count the number of uh, ones that we are going to get. First, let me take the input n, then let me create this array. Then let me take the input real quick. And then let me take create a count and count 1 which is 0 for plus plus a simple count of I equals to 1 count 1 plus plus. Also we can add end count 0 and same check but for 0 equals 0 count 0 plus plus. Right now We can include as many number of zeros as we want. We must exclude only one in one subsequence, and we cannot exclude any number that is greater than 1. Great. Now, for any one number of 0 that we include, for 1 0 we have two choices, right? We can either include it or exclude it. So for two zeros, how many choices will we have? Which is 2 into 2, 4. So for n number of zeros, how many choices will we have? 2 to the power n, correct? Uh, because for one choice we have, for 1 0 we have two choices. So for n number of zeros, we will have 2 to the power n number of choices. So that gives us uh, the total, let's say we have this, right? So long total will be the count 1 into math.pow. Okay, it takes a double. Can we, I mean, we can make it a double 2 comma double count 0. Does that work? I don't think so. Oh, we need to make this double as well, right? All right, great. So, like, how does this work? So if we look at the example that we have, which is 30211, total sum here was 7. So s minus 1 is what? 6. Now let's count the number of zeros that we have, which is count 0 that we have is 1, and the number of ones that we have is 2, right? So count 1 is 2. So can't we see that 2 ones and 2 to the power 1 gives us 4. So hence the 4 valid subsequences. Uh, because we can either exclude this one, we can either exclude this one, we can either include this one, or we can either exclude this one. So two choices. Two choices here and one choice here. So that gives us 4 choices. Correct? And that is how we got 4. 2 here, 1 here. If we add it, we get 4. And if we put this diagram that we have into math, it becomes something like this into the count that we had, which is 2, right? So 2 to the power 1 is 2, and 2 is 2, and this becomes 4. Hence the answer, right? So this will give us the answer, and we can just directly println total, print this answer. Okay, let us do a quick check. Let me copy from the input that we have, and then let's run this. All right, so we got in this format 10244, which is correct. But we're getting in the double format. I think we could type safe it into int. Let's see. Yep, there we go. But this might cause an issue in the submission, but let's see. We'll face it when we get there. So let us submit this real quick. A great problem, again, by Codeforces. This is why I prefer Codeforces above Lead Code. It's just attention to detail in the problems. Uh, Like my mind was always going to DP because it's ingrained in me that if I see a subsequence, it's a DP problem. But I was like, again, it's a 900 problem. Why would they? I mean, it is possible that they could give DP for 900, but in the problem stack as well, it was given math. So I'm like, okay, it's if they've not added a DP tag, then and also like it's not literally possible as well to do DP because as we saw, we could only give n or n log n, right? And a DP problem, even if you do tabulation, it's n square, right? So yeah, because recursion, correct? I mean, I don't know if DP can also be done in O of n, but what I know, what I have done till now, from my little experience that I have, I think it's always n square or more. So, I mean, the normal recursion is exponential. So, anyway, enough talk. Let us go and submit this problem. Where am I saving it? Luntik and subsequences. There we are. Submit. Let us see. Let us see. We bring this here. You can see NQ. Okay. Have I saved it? No, I did not. Shit, it's going to give me an error. Why do I do it every single time, guys? I'm sorry. I don't know why I do it every single time. Submit, submit, submit. This one. Let's see. Let's see. Let's see. Let's see. The only issue that I'm thinking of is that double to int. Yeah. I think the double to int is not the best thing to do. Okay, so I use this math power function, but I think there's something very uh, cute thing that we can do here uh, using bitwise operations, which is 1L shift count 0. And this literally does the same thing. I will not go into it a lot until we see a bitwise, but this is a very great substitute for allowing us to, you know, do the 2 to the power calculations uh, in a 64-bit format instead of the double, which is, I think, 128. Uh, Let me search real quick. I don't want to give wrong information. Double is 128 bits. No, a double is also 64 bits. Then what is the difference? Double is difference between a float and a double. I think, oh sorry, not float, long and double. I think it's just because of the fraction that we can calculate. Yeah, long only stores whole numbers, whereas double stores fractional numbers. Got it. Great. Awesome. So, 64-bit whole numbers, which is what we want. And we can remove this and let us try and submit this again. Um, Let me bring the code forces here itself. Let me go to this, go here. Have I saved it? I have saved it. Submit, submit, submit. Let us see. This should work. I'm hoping. Let's go, guys. Brilliant. Awesome. So this is solved in 50 minutes. Again. So this was a great question. Why isn't it verified yet? Did it solve it, guy? Oh, okay. I think I was late. Great question. This was also a good question. mean, yeah. All right, guys. With that, I will see you in the next one. Until then, let me just rename this quickly so that it doesn't show an error next time I open it. Great, great, great. All right. All right, guys. Thank you. It's late here in India. It's 11:49 p.m. and I'm looking forward to sleeping because I had a rough day at work as well. And yeah, tomorrow is a big day. We are going to solve another problem tomorrow. But until then, stay happy. I hope you achieve all your dreams, all your hopes and dreams. And I don't know what to say. Bye bye. Get out of here.